Okay, so in this video here, we're going to be talking about solving quadratics by completing the square. Let's go ahead and start our first example here. And the first thing that we need to talk about, when you are completing the square, you have to make sure that you are in this format right here, where you have x squared plus or minus bx equal to c. Now, this plus or minus right here is indicating that your bx term could be either negative or positive. So just keep that in mind. And so if you look at the quadratic that I have right here, I'm not in the correct format because my constant is not on the right-hand side, right? I'm going to have to move that negative 20 over to the right-hand side, and then I can go ahead and complete the square. So let me go ahead and do that. If I do that, remember, this is equal to 0. So if I move it over, it will become positive 20. So I'll get x squared minus x equal to positive 20. And then from here, I'm in the correct format. So I can go ahead and complete the square. Now to do that, you're going to do b over 2 squared on both sides, and you're going to add that. So for example, you're going to do b over 2 squared, and you'll be adding that. Now my b here is going to be a negative 1, right? My coefficient in front of this x is a negative 1. That's my b. So I'm going to put negative 1 here over 2, and then I'm going to square it, okay? Now what I like to do at this point here, I like to circle b over 2 simplified because I'm going to use that value later when I go to factor. And that will always work out when you're completing the square. And that can be really useful because if you're dealing with fractions, factoring it at the end can be very complicated. But if you know that it's always going to be b over 2 simplified, it can make it way easier. And you'll see what I mean here as we go through the problem. But I'm not done yet. I now actually have to do negative a half and then square it. That would give me positive 1 over 4. So what I'm doing here is I'm adding 1 over 4 on both sides. So let me go ahead and do that. I get x squared minus x plus 1 over 4 equal to 20 plus 1 over 4. So once you add b over 2 squared on both sides, you want to go ahead and factor your trinomial that you have right here. Now factoring it is going to be really easy if you circled b over 2 simplified. That's this value right here, negative a half. When I go to factor, it's going to be the following way. I'm going to have x, and then whatever that value is, in this case here, negative a half, I'm going to put that right here, and then I'm going to square it. And there it is, completely factored. That will work out every single time, so that's how you can factor that trinomial. Again, if you were to expand this out right here, you are going to get this quadratic trinomial above, okay? So a little trick you can use there. And then 20 plus 1 over 4, I'm going to go ahead and combine those. So equal to, now 20 is over 1, and then plus 1 over 4. So I essentially have to multiply this fraction here, both top and bottom, by 4. That will give me 80 over 4. And then I can add the numerators. So I'm going to do 80 plus 1. I get 81 all over 4, right? That's how it's going to work out. And so from here, you want to get rid of this exponent right here. How do I do that? I take the square root on both sides. So if I take the square root on both sides, I get x minus a half equal to, now remember when you take the square root, you always want to put plus or minus. So plus or minus square root of 81 all over 4. And that square root is being applied to both the numerator and denominator. So I'm going to take the square root of 81 here and also the square root of 4. That will give me 9 and 2. So then I have x minus a half equal to plus or minus 9 over 2. And then your last step here, you want to add this negative a half over. So you're going to get x is equal to positive a half plus or minus 9 over 2. And you could leave it like that if you wanted to, or you could write out the individual x values because they have the same denominator here. So I can just go ahead and combine the numerators. So I'm going to do 1 plus 9 and I'll get 10, and then divide by 2, I get 5. So x is equal to 5. And then doing the other one, if I do 1 minus 9, that will give me negative 8. Divided by 2, I get negative 4. So x is equal to negative 4. This is where the quadratic is crossing the x-axis. It's crossing at 5 and negative 4. All right, so let's go ahead and try another example. So here's my next example. And again, your first step, are you in the correct format? And I'm not. I have to take this positive 6 and I have to move it over to the right-hand side. So now I'm going to have x squared plus x and then equal to negative 6. Now, if I'm looking at it, I am in the correct format, right? I have x squared plus bx equal to c. I'm good to go. I'm going to do b over 2 squared on both sides. So b over 2 squared equal to, now my b here is going to be 1. So I'm going to get 1 over 2 and then squared again. And then I'm going to go ahead and circle this part here. This is b over 2 simplified. Again, we're going to need that later. So this will be equal to 1 over 4 when we finally square that value. So again, just like the other problem, I have to add 1 over 4 on both sides. So I'm going to get here x squared plus x plus 1 over 4 equal to negative 6 and then plus 1 over 4. So remember, factoring this quadratic trinomial is really easy. You look at b over 2 simplified, and then you put it right in factored form. So in factored form, it's going to be x, and then here comes b over 2 simplified. That's positive a half, so plus a half, and then squared. And that's done, okay? And then equal to, we want to combine right here. So that negative 6 is over 1 plus 1 over 4, meaning I'm going to have to multiply this fraction right here, both top and bottom, by 4. That way I can match that denominator. When you do that, you get negative 24 all over 4, and then plus 1 over 4. Okay? So you can see here I can add the numerators now. I'm going to get negative 23 all over 4. Okay? Now from here, you want to take the square root on both sides. That way we can get rid of this exponent of 2. When I do that, I get x plus a half equal to plus or minus square root of negative 23 all over 4. Okay? So you have a negative number underneath a square root. You're going to end up pulling that out and making it I. But remember, this square root is being applied to both the negative 23 and the positive 4. So I know that the square root of negative 23 is not a perfect square. I'm not going to be able to do anything there. But the square root of 4 will be 2. So I can rewrite this the following way. I can say x plus a half equal to plus or minus. Now again, I want to pull out this negative here. I don't want that negative to be there. So when I pull it out, I pull out an I. So I'm going to put I here, and then I'll have square root of 23 all over 2, because the square root of 4 is 2. And again, the square root of 23, well, that's not a perfect square, so we're going to leave it as the square root of 23. And then from here, you're almost done. Take this positive a half and move it over, and you're going to get x is equal to negative a half plus or minus square root of 23 all over 2, and then we're going to put I on the end right here. Okay, so again, I'm just moving the I from the front and I'm putting it in the back. That's fine. Really doesn't matter the position where you put it, but typically you will see it on the end like you see here. Okay. So that's going to be our final answer. We don't have to go ahead and split that up. We can leave it all as one solution, right? And that's going to be done. All right, so just remember you do have two x values there, and your zeros here are actually going to be a complex number because, again, you have a real part, this negative a half, and then you have this imaginary part, square root of 23 over 2i, right? So technically, your zeros here are going to be complex. And so again, that tells you that if you were to graph this quadratic, it's not actually going to be crossing the x-axis. Your zeros are imaginary, right? Or in other words, complex here, okay? All right, let's try one more example. This one will be a bit more challenging. Okay, so here's our next example. Now, right here, we are not in the correct format. I have to take this positive 6 and move it over. So when I do that, I get 2x squared plus 5x equal to a negative 6. Now, from here, you're still not done. Because if you look at the template, I need to have a 1 here in front of that x squared. That's my coefficient. Right now, I have a 2. So think about what you need to do here. My recommendation to you, don't divide out the 2. So for example, don't divide by 2 here, here, and here, because what you're going to do there, you're actually going to be changing the shape of the quadratic, okay? You won't actually change the zeros. So if you were to graph like the original quadratic right here, and then you graph the quadratic where you divide all your terms by 2, you're going to see that the general shape of it is going to change, but the zeros won't actually change. However, it's always a good practice to go ahead and factor out rather than divide out. That way we're not changing the shape of the quadratic and everything is staying consistent, all right? So rather than divide here and changing the shape of that quadratic, let's go ahead and pull out a 2, or in other words, let's factor out a 2, okay? So let me go ahead and get rid of all this here. So if you factor out a 2, you're going to get the following. You're going to get 2, and then you get x squared. And now think about, how do you rewrite this term right here if you factor out a 2, because technically it never had a 2 in common, right? So this one's not very obvious, but you're going to write it as plus 5 over what you pulled out, in this case here 2, and then you get x. And so you can see what's going to happen here. If I redistribute the 2 inside, I'll get the 2x squared, and then the 2's will cancel out on this fraction, and I'm left with 5x, what I originally had, right? So that's how you go about doing a problem like that. All right, again, it's not very obvious at first glance, but once you take a look at it, you'd probably figure it out. And then I have equal to a -6. So now I am in the correct format. Again, I'm looking at this part right here, and this 2 is just going to come along for the ride. Okay, we don't really care about that 2. We'll take care of it at the end. So I'm looking at that part inside parentheses. I'm ready to go ahead and complete the square. So in this case here, b is going to be 5 over 2. So I'm going to do b over 2 squared, and then plugging into b, I'll get 5 over 2, and then all over 2 squared, right? Equal to, so think about what b over 2 simplified is going to be here. Think about keep, change, flip. So I'm doing 5 over 2 divided by 2. So if you do keep, change, flip, that's 5 over 2 times 1/2. Or in other words, 5 over 4. So I'm going to rewrite it as 5 over 4 and then squared. And then I'm going to go ahead and circle this part here. That's b over 2 simplified. I'll need that later when I factor. And then finally, applying this exponent to both my numerator and denominator, I get 25 all over 16. So I have to add 25 over 16 on both sides. So I'm going to go ahead and do that. So I have 2 and then times x squared plus 5 over 2x and then plus 25 all over 16 equal to -6. Now be careful here. Typically, you would just go ahead and add 25 over 16, right? That's b over 2 squared. But what are you actually doing here? Because remember, we factored out a 2. So if you were to distribute this 2 inside, it's not actually 25 over 16. It's actually going to be 50 over 16. So I'm going to put here plus 50 over 16. And we can actually reduce this fraction here, this 50 over 16. So we know that 2 will go into 50 25 times, and 2 will go into 16 8 times. So rather than write it as 50 over 16, I'm going to go ahead and write it as 25. So 25 all over 8. Okay, so from here, we need to get a common denominator. And I have a -6 over 1 plus 25 all over 8. And so what we can do here, we can go ahead and multiply this fraction here by 8, and that will give us the common denominator that we need. So when I do that, I get the following. I'm going to get -48 plus 25 all over 8, right? Just multiplying, again, this fraction by 8. And so when I combine my numerator now, I'm going to get -23 all over 8. And I'm just going to write it here for now. That way when I clean this up, I know what I'm going to get on the right-hand side. So cleaning it up now, I put 2, and now this part here is going to be super easy to factor. Now, if you didn't know about this trick of b over 2 simplified, you would have to try to factor this part here, and you can see that's going to be an absolute mess. But since I know it's always going to be b over 2 simplified, I can just go ahead and write here x plus 5 over 4, because that's b over 2 simplified, and then squared, and then I'm done. Equal to, this part here is going to be -23 all over 8. Okay, so from here, I have to go ahead and solve for x, but first, now I have to divide out this 2. Okay, so I'm going to divide out that 2. Let me go ahead and scroll down here. So dividing both sides by 2, that will cancel here, and dividing this side by 2. So again, think about keep, change, flip. You're going to end up getting -23 over 16 when you do that. So now I have x plus 5 over 4 squared equal to -23 all over 16. Okay, now we want to take the square root on both sides. So I get x plus 5 over 4 equal to plus or minus square root of -23 all over 16. So we know that 23 is not a perfect square, so that's going to remain as the square root of 23. And we know that the square root of 16 is a perfect square. That's going to be 4. Also, remember, you do have a negative here, so I have to pull out an I. Okay, so rewriting this, let's scroll down. We're going to get the following. We get x plus 5 over 4, and then equal to plus or minus, here comes my I, I'm pulling out that negative, and then square root of 23, and then all over 4. Okay, and then my final step, move this 5 over 4 over, and then I'm done. So doing that, I get x is equal to negative 5 over 4 plus or minus square root of 23 all over 4, and then I'm going to put the I on the end. So then I put I right here, okay? And this is now done. Okay, we can leave it just like this. We can leave it as one solution, that's fine. Just remember, in the solution, you actually have 2 zeros, and these 2 zeros, again, are going to be complex, meaning this quadratic is not actually crossing the x-axis, okay? So that is it. That is how you can solve a quadratic by completing the square. It's pretty straightforward. Just make sure you're in the correct format. And remember, always circle b over 2 simplified because it's going to make factoring much easier. So I hope that you found the video helpful. I hope that you gained something from it. If this video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe, that way you get more math videos in the future, and I'll see you in the next one.